Okay, so we had some great presentations regarding how to solve systems of linear equations using 3 different methods. I wanted to highlight 2 examples of our classmates that I think help bring this to life. So the first one, the scenario is the following. For the Platt homecoming dance, here's what we know about the dance, right? We know that there were a certain number of tickets sold in advance, and these were $5 each. And then we know that there was a certain number of tickets sold at the door. And those were $7 each. And we know that there were 290 students who attended. And there was a total of $1,790 in sales. And the question is, how many advance sale tickets were sold? How many tickets were sold at the door? Okay, so here's the scenario. Right? We can use some variables to describe the situation. And we can create 2 equations given the information we have. That would give us a system, and we would be able to try the different methods to see if we could solve it. So I'm going to let x equal the number of tickets sold in advance. Okay? And I'm going to let y equal the number of tickets sold at the door. And here are the 2 equations that I can write. The first equation I can write is, for the advance sale tickets, right, however many of those were sold, they were $5 each. However many at the door tickets we sold, those were $7 each. And altogether, I know that we sold $1,790 worth of tickets. So there's one equation. Right. Here's the second equation. I can describe, using the 290 students, that however many tickets were sold in advance, well, however many tickets those were, that's how many students attended the dance with an advance sale ticket. However many tickets were sold at the door, that's the same as however many students attended with a ticket sold at the door. And altogether, I have 290 students. Okay? So these are 2 very nice equations that I could work with. Now, if I'm thinking about methods I might use, I don't know that I would love graphing here because I've got some pretty big numbers. I could do it. I might set up a scale using, by 50s or, or even more, but it's not convenient. I could, come up with the intercepts and all that good stuff, but I just am not loving it because of the scale. So I'm going to model substitution and then elimination using this situation based on what we discussed in our presentation. So let's start with substitution. Okay, if I'm using the substitution method, I'm going to try to describe one of these variables in terms of the other. So, for example, since I have x and y here, I could go either way. I'm going to decide to describe x in terms of y. Okay? So if x plus y equals 290, then I know x equals negative y. I got to subtract y from both sides. Okay? X equals negative y plus 290. All right. And I can use that description of x and substitute it in to my other equation. So I use this equation to come up with a expression for x in terms of y, right? X equals negative y plus 290. I'm going to use that value in this equation here. So 5x plus 7y equals 1790. I'm going to replace x with y. With my expression for x in terms of y. So I'll say 5 times, well, what did I say x is equal to? Negative y plus 290 plus 7y equals 1,790. Okay, and as I continue on here, I'm going to need to distribute negative 5y plus 5 times 290 plus 7y equals 1790. All right. So 5 times 290, I will tell you I'm quite tired, so I'm even pulling out the calculator. I don't need to, I'm sure, but 5 times 290, since we're multiplying by 5, that should have been perfectly simple, is going to be 1450. Okay. Negative 5y's plus positive 7y's, that's 2y. I'm going to subtract 1450 from both sides. And I've got 2y equals 340, or when I divide by 2, y equals 170. Okay. So given that, now that I have a value for y, I can choose either of my original equations. Okay, so let's go back up here. Either of my original equations to put that value in and solve for x. Well, I like this one very much because it's just simpler, right? So remember, this solution has to make both equations true. Well, we used one of the equations to come up with an expression for x in terms of y. We substituted that into the other equation to come up with our value of y. And, you know, I have choices, but I'm going to go with x plus y equals 290. X plus 170 equals 290. When I subtract 170 from both sides, I get x equals 120. Okay? So this is telling me that the ordered pair that should satisfy both of these equations would be x is 120, y is 170. Okay? And I can check that just by going back up. If I put in 120 here, well, 120 plus 170 is indeed 290, so that works. And then if I check up here, 5 times 120 plus 7 times 170. When I check out my calculator, 5 times 120 plus 7 times 170 indeed gives me 1790. So that solution appears to work for both, which would tell me that 120 tickets were sold in advance and 170 tickets were sold at the door. Okay. So now let's look at the other option we have. We did the substitution method. Now I'm going to try the elimination method. Okay, and you can always choose which one you're more comfortable with once we've had sufficient practice with all of these. So with the elimination method, I've got 5x plus 7y equals 1790. I've got x plus y equals 290. And I want to try to combine these equations where if I take this first one, I can add or subtract the left side and the right side of the second one. Okay, this is just rooted in the algebra. To do that, I'm looking at these guys here and thinking it would be great if I could drop out my x terms. Okay, but to do that, I would need to multiply both sides of this second equation. I'm going to multiply both sides by negative 5. So I end up with negative 5 times x negative 5 times y, and negative 5 times 290, which is just negative 1450. Okay, so all I did was restate this equation, x plus y equals 290. I haven't changed it because I've only multiplied both sides by the same amount. I'm just using this restatement so that I can take the equation here, 5x plus 7y, and since I know I can add the same amount to both sides of an equation, that's what I'm going to do. So I'm going to add this to 5x plus 7y. Well, 5x plus negative 5x, gone. 7y plus negative 5y, 2y's. And 1790 plus negative 1450 leaves me with 340. Okay, and that should look kind of familiar from what we had down here. 2y equals 340. Y equals 170. Okay, just like we found over here. And then I'm going to take that y equals 170, and again, I can substitute it into one of my original equations, which again, I would choose to use x plus y equals 290. Okay, and I'm not going to show that work because it's exactly the same as what we had here. By doing that, putting 170 into, for y into x plus y equals 290, I'll get x equals 120, and I end up with my solution of 120, 170, which has the same meaning as it does here.